Thanks. That saves me a lot of time. And so, as you can imagine, this is a segue lecture. It's going to be a little bit different than many of the other presentations this morning. And I think that when I mentioned this to my wife before leaving, she reminded me that if there's a segue involved, I should probably be wearing a helmet. I'm gravitationally challenged, and I ought not to hurt myself. But anyway, so let me talk about what we're actually doing, because we deal a lot with words and nomenclatures and some of the problems that that can cause. Now, the other thing is that in November, we've been working with JGI for a long time, and I got a call from Kirsten Fagnan, who's one of the collaborators on the project that I'm going to discuss at the end of this session. And there's a kind of a problem, and it's a kind of a big one, and that is, who's using my data? This is a question that we all want to know, because we're producing all of these wonderful data, and we'd like to find out what happens with them. But when we ask about who's using your data, how do you actually develop some kind of a web service or some kind of tools that will allow us to create a new metric that not only tells us who's using the data, how it's used, where it's used. And in fact, when you begin looking at data and its use, it's not just the experimental data that perhaps a grad student, a PI is going to be generating, or you have a sequencing center generating. Much of the data that we generate winds up finding its way into a number of different places. It's in publications, it can be in regulations. Many of the regulations may govern the kind of samples that we pick up, especially when you get into CBD and the Nagoya Protocol. And so there's this great big web of information. And when you do taxonomy and nomenclature like I do, we also have to worry about how we ship materials, and we have to worry about things like the International Airline Transport Authority and many other organizations that want to know what's in the box, how do we move it. First responders need to know how you're dealing with it. So there's a lot of needs for not only knowing what's in the data, but also evaluating what to do with the data. Clearly, BER needs to know what's happening with all the data that's being generated by the JGI. They'd like to measure its impact as well. So there are a few things that we want to consider when we start solving this problem, or thinking about it at least. One is data attribution. This is really important. We'd like to get credit for the work that we do. And remember that each piece of data that we generate has some kind of ownership associated with it. There's also data provenance. So when you put a piece of data into a data system, you want to know where it came from. You want to know what rights are associated with, what obligations are associated with it. And all of this information needs to stay with the data as it's being used. And as it's disseminated from a local system to a global system, it becomes really important, because you'd like to not only give credit, but you also need to know whether or not you can actually use the data and what other kinds of obligations and rights are associated with it. Now, if we want to go beyond the local system and into a global environment, now we need to worry about a couple of other things. We need to know, how do we discover the data that's in a system? What kind of identifiers, what kind of mechanisms do we have to actually find out what's there? And then, once we get into the web environment, how do we find it? How do we find it on our own websites? How do we find it on other people's websites? And what kind of a series of links can we follow to find out what happened to the data from the point in which it was first generated until the time it's used in the literature and many other places? Now, what's really important, and what you learn in taxonomy, is the importance of a description. If it's a piece of data, if it's an organism, you want to be able to describe it accurately. What is it? How do I know it's yours? How do I know that you found something that might not have been found by somebody else before? And so we need to actually have some place, if we're going to follow things, where we actually have a concrete description, and we can go back and we can refer to it. If we're doing something novel, something new, there's something completely different, we want to be able to go back and look at this as a reference point, or do we want to essentially amend the data that's already there and essentially add new knowledge to the existing knowledge? Now, the other thing is, when we look for data, we have two ways in which we're approaching it. One of the things we've seen in this meeting and many other meetings are it's nomenclature. We're seeing lots and lots of biological names. Do you folks know what those names mean? Do you understand that at some point in time there's a description, there's an organism associated with it, there's a whole history, and if you understand the nomenclature, it allows you to understand the taxonomic thinking, but what's equally important is that you need to understand that nomenclature is regulated but the taxonomic thinking is not. And if we try to regulate the taxonomic thinking, what happens is everything stagnates. We have a group of names, our knowledge can't move. And so we're always essentially changing taxonomic thinking. We give new names, and there's a wonderful set of rules that we use. It's called the International Codes of Nomenclature. They have them in botany, zoology, virology, and prokaryotic biology, and they tell us what the operating business principles are. Now, the thing about names is that they're ambiguous. Names are also not persistent. They're going to change. I just told you that, right? They're constantly changing. And the other thing is that they don't do it in a predictable way. And names also, especially biological names, carry a lot of meaning. In fact, if you try and create a name today, my good colleague Aaron Orn is going to not only Latinize it, but he's going to suggest what the meaning of the name should be, where it comes from, what its shape is, some other kind of information. But the problem is that when you have names, you run into two problems. Not only do you have the ambiguity, but you also have the other part of the problem. It's known as induction in linguistics. The names, the terms, the concepts that we use are constantly changing. So we have to have a way of mapping out all those changes. Now, the other way we can search for data is with identifiers. We've heard a little bit about identifiers during this meeting, especially persistent identifiers. Persistent identifiers are the opposite of names. They're guaranteed to be persistent if they're properly done. They're unique. They're never going to change. And they're going to be around for a very long time, and they carry no information, unless it's some kind of a numbering system that you need to know. And so what we want to do is search for data using both of these methods, and then how do we actually join those together? So what I'd like to offer today is this concept about a research artifact. When you go in a laboratory, when you generate data, when you collect organisms, we're all out there creating research artifacts. And associated with those research artifacts are pieces of information. Those pieces of information are things that we want to persist. We want to be able to attribute them to the individuals that collect them. But they're digital pieces of information. They may be used in one experiment, multiple experiments by others. We'd like to be able to track them. And so JGI generates millions of these research artifacts. And they're not the kind of artifacts that you think about in the experiment when you go, oh crap, it went wrong, and you're kind of pulling your hair out. But these are kind of the artifacts that are like anthropologists look for. They're remnants of what people have done. And they're very important because they provide us a path forward, and they kind of anchor our knowledge. And so why us? So Joshua has kindly given you a little bit of information about the company. So let me just tell you, we are an STTR project. What this means is that we've been commercializing a technology that we essentially created at Michigan State University during a long-term project that I've been involved with now for about 20 years. We work at an intersection between linguistics, text mining, publishing, and taxonomy, and what we've been developing is a whole series of tools that allow us to identify information using name entity character recognition, extracting information, classifying content, and doing ontology development and thesaurus development. So when we talk about taxonomy, it's not just biological taxonomy, it's taxonomy of concepts, building hierarchical networks and then essentially using that for knowledge engineering studies. And the idea actually came from another invited lecture, and these are always great for me because it always makes me think about what I'd like to do. And to some extent, these kinds of opportunities are selfish on my part as well. And so Catherine Lyons, I was working with Catherine Lyons on developing the document type definition that was used for publishing the second edition of Berge's Manual, a systematic bacteriology. And Catherine and I were developing the document type definition, taking an ink and paper publication from an old technology into an emerging technology that's now essentially an XML-based technology. And we knew that one of the real problems that we were going to have was going to be biological nomenclature and how that's used in indexing content and retrieving content in a very, very large multi-volume work. And we knew that this kind of problem also was something that we might be able to solve. Catherine was also sitting on the IDF, the International DOI Foundation. The DOIs were just coming into use at that point in time. They were a creation that came out of the Handle system used in libraries. That was developed by the Corporation for National Research Initiatives. And we were thinking, wouldn't it be nice if we could use DOIs to essentially anchor them to names? And then this would be a way of essentially persistently flowing information about microbiological names back into the content. And so it didn't matter what name you used. This information would all flow right away. And the other thing is that we could keep content up to date. You could use any name that you wanted to use when you're searching for literature, and you wouldn't miss anything. Now, it took a little bit more than just doing this. We actually use a proprietary semiotic model that uses redirection across not just one DOI, but 3 DOIs. And what it allows us to do is now create a information object for a name, which is an event, a taxonomic thought or taxonomic idea, which is a separate DOI, and an exemplar DOI, which exists at the species or subspecies level when you're using this application for microorganisms. And what we develop are curated objects, and these curated objects then allow us to essentially create a whole series of different web services. And those web services have been in use now by the Microbiology Society in the UK for a number of years. And what it allows us to do is then to mark up the text, as you can see, and provide a whole series of web services where we're now flowing updated information that's maintained outside of the journal and updating all of the content. If you're interested in finding out what the organism is, if you're interested in finding out what the name, the references, any of this information, it's sitting right there. All you need to do is click on a link. As these are DOI products, not only can we serve them the way I just showed you, we also need to serve them as DOI landing pages. So if you query our DOIs using http://doi.org and attach our DOI, what this will do is then bring up a series of information-rich, basically micro publications that give you information about the organisms, and you can then navigate all of these documents one after the other. So this is what the taxonomy looks like kind of schematically. As I've already told you, we have these different objects, and the real kind of activity, the biological activity, is at the level of the exemplar. And then mapping in through the DOI is also another concept that we call the practitioner. Thank you, Emma, for bringing up the concept of practitioner. I thought I'd be the only one using that term today. But the practitioner is a scientist who's actually collecting the organism, describing the organism. Each one of these pieces of information may have a different practitioner or multiple practitioners. And what this allows us to do is reorganize a taxonomy nightly, pretty much on the fly, based on what's been published during the day. This is an example of what we do, and this is information that we provide to our clients. We're also providing this to the GIBA project. We maintain several taxonomies. One is what we call a complete taxonomy that has all of the nomenclature with the synonyms, the homonyms, the isonyms, and many of the other ambiguities. We also have a condensed taxonomy in which we strip out all of that information and just go directly to the type strains. And so you can see that there's a difference. There's about 4,000 names that are ambiguous out of 20,000. So that's about a 20% ambiguity factor. We also have high-quality 16S sequence that we distribute. Keep in mind that not all of the organisms that have names have a type that's in culture. And so we have some organisms that were grandfathered in that are nothing more than a figure or a description someplace in text that might go back into the 19th century, but they still have standing in our nomenclature. This also allows us now to figure out where we stand with the number of type strains that we're sequencing in the GIBA project, as well as re-annotating all of the genome assemblies that are published by NCBI on a nightly or monthly basis, and we do this on a monthly basis. Now, one of the other things that's kind of interesting is that there are times in which you can apply a taxonomy, and it may be good for a short period of time, but there may be radical changes. This was a series of experiments that were done for the fun of it. Turned out to be a kind of a big experiment, though, where we're looking at a series of mixed 16S metagenome data sets. And what we applied to that same metagenome, those same mixed metagenomes, were taxonomies were generated at different time points using the 16S data sets as they were at a particular point in time. Now, last year, between August and September of 2018, there were over 1,000 changes in nomenclature to the actinobacteria, the mycobacteria, and the mycoplasma. And what this means is that when you apply a nomenclature to the metagenome at one point in time and you go back and collect it again, the names that you're going to assign to the OTUs have changed, sometimes rather dramatically. And so what we can do is use the Kolmogorov-Smirnov test statistic and actually find out what the bandwidth is and let us know if the taxonomy that we're using is still relevant for the period of time that we're working in. And if it's not, we have an ability to go back and change it out, re-annotate, and then bring everything back into the same frame of reference. We've also developed some other tools for publishing. I know a lot of people have problems when they essentially submit manuscripts. And so what we've developed are some tools that will allow you to essentially scan a manuscript into web service. We mark it up. We essentially check your nomenclature, tell you if it's current, wrong. We check all of your IDs, and we provide the annotation at the end of the article. So either you, your editors, copy editors, or others can actually go back and fix the problems and make sure that your manuscript is as clean as possible before it goes to print. We've also been developing some other tools. These are the way in which we index the data. Our contextual index is really an index of a series of different pointers or different identifiers. This is essentially something that we pick up and do on a nightly basis as we scan the literature and find out terminologies, how they're used in articles that we're looking at. Our semiotic index is one step further, and what this allows us to do now is to use an entire vocabulary to search across that entire vocabulary at any level in a taxonomy and essentially filter the document. So I'll show you what we've done here. On the left and the right-hand side is the nicest heat map I've ever drawn, and this is for real. We looked at 300,000 patents from the green technology space in the EU. We classified them using the ECLA classifications. There's about 100,000 different patent categories, and we essentially ran through 3,000 patents that were associated with microbial patents. And we essentially looked at the orthogonal axes, looking at organisms, patent classifications, and then classified the patents into the existing technologies with the organisms that were used. But think about it, we used over 15,000 names in one query. That's a lot of typing on a Google query bar. On the right-hand side, don't know my right from my left, I think, is another example. We did this for the USDA patent culture collection. All patented microbial products need to have a patent deposit in a culture collection, and what this requires is that the material be available to produce exactly what's claimed in a patent. If it's not, you lose your patent rights. What we did was we looked at all of the organisms that were in the collection and wanted to know which patents had expired, which organisms could be released for general public use. But at the same point in time, we went through the patent documents and we decided, well, why don't we take a look and see what the patent classifications were, what the companies were, and this now allowed us to go through all the organisms, find out what the companies were doing with the organisms that we're using and the kind of patented technology. And so when we heard Amanda Hurley speaking yesterday, she did a great job in telling us how important the patents are. And this is really where all the information is if you want to start looking for antibiotics. It's not in the scholarly literature. There are 85 million patents to go through, and you need to essentially be able to mine those, and the documents are a little bit different. And so what we've done is we've built out a whole series of tools to allow us to develop very fine-grained terminologies that we can use to essentially go through this kind of content very quickly, and we can essentially develop not a controlled vocabulary, but a vocabulary as it's used in a particular body of literature as narrowly as we want to find those terms that are going to be diagnostic to find the kind of information that we're really interested in. And we can do this in a period of a few days by looking at large collections, thousands of documents, and do this very quickly. One of the other things that we use the same technology for is I've been an editor for a long time, and finding peer reviewers is hard, right? How many of you get requests 2, 3, 4 times a day? Will you please peer review this manuscript? this is a chore. And so what we did was we took some of the other technology we had looked at, and what we do is we'll scan a manuscript, do a semantic comparison of a manuscript to a corpus of 5 years worth of work in a particular field. So we're interested in genomics, we get a paper in genomics, we scan it to 5 years of the open access literature, and we do a semantic comparison. What it does is it tells us who the authors are, who are working in this area, who we might be able to approach based on their credibility as an author based on the number of publications that they've written, and it also allows us to craft automatically an invitation letter, and that invitation letter now relates the paper that we want to get a peer review to all the work that the author has done that's related. It's a hook, but it's sometimes an important hook. Otherwise, people are just going to discard it. Now, the experiment that we've been doing with JGI is a kind of an interesting one because the question is who's using your data and what happens with it. And so we looked at the different points, and the circles are essentially representing a series of different kinds of identifiers and external resources and internal resources. And we essentially take the literature, we bring in the metadata based on identifiers. We have identifiers for all of our data, and then we have a whole series of other identifiers that are used at JGI, NCBI, many of the other places that we look at. And what we want to do is now map through all of the data and see who's actually using the JGI resources. More importantly, who used their JGI resources but didn't cite it in their references. Now, the way we do this is we essentially collect, once again, the information that we're looking for in the open access literature. We go through it, we mine it with our contextual index. JGI is now feeding us their data through an API that's under development. We add that to our metadata and essentially do the join, if you would, and essentially pass the information back to them. So what we're doing is we're expanding the metadata with all the information that we find. And then we also update our contextual index, and we use that and essentially serve out on our side the JGI and other data as well. So on the right-hand side, on the left-hand side, looking at left and right at the same time, is the record that we received from JGI. It's a phytosome. This is the most downloaded downloaded data set that came out of JGI. There were 2 PubMed citations for this particular piece of work. After we expanded the metadata, we ran against 2 million articles. It took us about 7 seconds to go through our index to do this. We were able to find 109 citations of the same product. And so this tells you that people are actually using your data, but you may not be aware of it. You ought to be getting credit for that, right? You get credit for the papers you publish. Why aren't you getting credit for the data that you generate? Why isn't BER, JGI getting credit for all the work that's being done? What's also interesting is when you look at the pattern of the citation, you can look at spark lines and you see that there's some initial interest, and then all of a sudden we get these big peaks. What's going on? This now gives you some other clues, and you might want to go back into those references and find out if there's some really important discoveries that have been made. Something new. So who's using your data? This is what we know about the data that we generate. This is from this morning. Right now, the Names for Life site is getting someplace between 6 and 7 million hits per year. And we have about 500,000 inbound links, so we're averaging around 500,000, 600,000 connections from the outside to our resources, and that's information that we serve back out. Our information is embedded in publications with the Microbiology Society, not only in the HTML, but in the PDFs as well. So our links are persistent, and this information is constantly being updated. And so what we think what's really missing from this, we're generating data so you have this kind of information that you want. We have a practitioner ID. It's called an ORCID ID, which is about as good as we could have done when we first proposed this concept. And so if you use the ORCID ID and you have one, we can simply make the connection between your ORCID ID and the data that you've generated, and now we've closed the loop. Now we know who's using your data. We have a way of measuring this, following it, We know the publishers are coming in their site and they're looking at what we're doing, and so now we can essentially pass that credit out, and we can start giving you credit. We can give JGI credit. We can give others credit. And we can find out who's doing things with our data that might be of interest to us. And so what we want to propose is this concept about a citable research artifact, so we can actually start building useful statistics, not the altmetric kind of statistics that are how many tweets did your article get. That doesn't last for long. Our tools allow us to go back into the archives. We can essentially update the stacks, all this information, and draw it forward, all the phenotypic information, the morphological information, the environmental information that might be missing from the current literature may be residing in the stacks, in the publishers, and in the open access literature. We can bring that forward and essentially make those connections and give credit where credit is due, and allow you to make new observations and to essentially extend the information on the knowledge that we have in a much easier and faster way. What we can do, though, is we need to make sure that we're doing this with good persistent identifiers, or URIs. We would advocate for digital object identifiers because it's an ISO standard, and it's used by the publishers. It comes from them, right? They're familiar with it. We've proven for a number of years that we can embed DOIs directly into their content. Has absolutely no impact on any of the downstream applications, and we can push information back into the literature. And so the conversation now is, how do we work together? We've done some interesting experiments, but it's really, I'm here today, as is Kirsten and others, to get some feedback. What do you need? What do you want? We can build tools that will allow you to essentially find out who's using your data, where it's being used, how often it's being used, which pieces are really important and which aren't. We can use this as a way of evaluating programs. You know, which ones are getting a lot of activity, which ones aren't. We can do a number of different things, and then the question is, where do we fit? We've been working with IMG and with the prokaryotic program for a number of years, and now we're starting to look at other places where we might be able to add this kind of information. Let us know. It's up to you. If you would like us to continue to do this, we'd be more than happy. And finally, I want to recognize two colleagues. One is Chuck Parker. Chuck Parker is not here, but Chuck is the guy who actually has done all the software development. He's an extremely gifted developer. He takes my ideas, and I'll do rough prototyping and bring it to him, and shortly after that we actually have real working systems. And we've had a number of different curators, and we also got colleagues at JGI, Nikos Karipides, TBK Reddy, and Jim Bristow, who was one of the early adopters of our technology, as well as some old friends at BER. Susan Gregorick, who was really a champion for us, along with John Houghton and Dan Drell. And I see it's probably lunchtime, so I don't want to hold up anybody from the really important stuff. So thank you very much for your time. I appreciate the opportunity.
Thank you very much, George. We have time for one question.
George?
Hi, Barney. What's up?
You mentioned the access to the open source literature. What about how much literature is closed that you can't search?
Well, right now, I mean, the thing is that if we have an agreement with a publisher, we can search their publications. And so that's something that we have to negotiate on a one-on-one basis. To us, by essentially going through and looking at where the other links are, we can also follow what's in Crossref, and we can know what might be cited in a abstract or some of the other information. But oftentimes, the really important information is in the article itself or in the supplementary data.
So do you have a sense of how large that pool of literature is closed or not available for you?
Historically, all of it. Today, maybe 80 to 85% of it is closed, but a lot of, say, the genomic literature and the other information is now moving very quickly into the open access. So there may be, for instance, in the UK, a 6-month or a 12-month embargo, and then it winds up going into the open access literature. If Plan S goes through in the UK, or in the UK and the EU, then all of it becomes immediately open, and there are no longer any kinds of restrictions in terms of what we can do with the content. today there's also sometimes discussions about what we can and what we can't mine, and we always respect that because we work with publishers. And the other thing I'll mention is that our tools operate not only at the front end for harvesting, but what we're doing with the Microbiology Society is that we work directly with a compositor, so all of our content is essentially integrated directly into the article during typesetting. And so we have the ability to do those sorts of things as well.